Happy Friday, everybody. So thanks for joining this webinar. So let us go through some slides to explain what we are doing today. The topic is especially around energies and utilities, and we have the pleasure to have our partner from Eximprod with there. So Angelos Fountoulakis, sorry, who is the channel sales manager of Eximprod. He is based out of Romania, and he has been very nice to prepare all the presentation and a discussion that you will see a little bit later. On my side, I'm still Damien Defer, the SixSq sales director at Equinox, and I'm very happy to present you this third webinar session. So I'm sorry, I will need to accept the people in the same time because I do miss. No, it's okay. Today we will talk a bit about SixSq and what we do in terms of edge computing. We will talk then about Eximprod and see a little demo of the solution. So what we have seen in the last years is a big trend of application moving to the cloud. So going to large data centers like Google or Amazon or whatever. But what we are realizing more and more is that not all application can be migrated to a central place. Especially some of them are very sensible to latencies, so they need to have to be very close from the equipments. Some applications are limited to the throughput, so you cannot send, for example, virtual, VR for big data stream through the network. And some applications, like we'll see today, are very important for the public sector. So you need to keep the data and the privacy in the network of the specific industry regarding energy, especially the energy sector. Plus, these applications are very network sensible, and they need to be working whatever happens on the network, and they need to be able to operate. So what we do at Equinox, we have a large set of network equipments with different hardwares, physical hardwares, like what we call flex CPE, which are devices that can provide or connect to 5G networks. We have small size, large size of different devices. We have devices specially designed for going into the energy sector with ruggedized hardware. And we have as well third-party vendors that we can leverage when we need to have some specific solution. So it could be Dell solution, Dell hardware with very large number of CPU and RAM, but it could be as well some very specialized hardware from LANer to fit into a specific environment. On top of that, what we do have is the operating system, so the Equinox One OS, that provides a large set of features. Many different network features, so which are about switching, routing features, security like filtering, and many different features, voice gateways, SD-WAN for having high availability between different networks, virtualization layer as well. If you need to have some specific features from other vendors, you can embed these as VNF inside the hardware. And as well, what is important is we have the Nebula Edge solution that brings a link to the Nebula.io platform, which is our edge computing marketplace. Inside this marketplace, we have more than 50 different vendors that we are working with, and EPG Eximprod is one of them, and we are very keen to have them today. So these different vendors provide features that are business-oriented or that can fit with specific requirements regarding new needs on the sector or from the different teams inside an organization. So what a customer can do, or a service provider, he can go on the platform and say, okay, today I need to have a specific solution for latency, for monitoring, packet capturing, or energy, and he can leverage the application that we have in the platform, which can be open source solution, which can be developed by vendors like Eximprod, or which can be private application. It means the customer, you can upload your own application inside the platform, and you can deploy it as much as you want, and it will stay private. So you can go inside this marketplace, select the application or the multiple application that makes sense for you, click and deploy them on all your devices where you need to deploy these features. So it can be routers, for example, that are deployed inside a subsecondary substation energy, or it can be in a truck, it can be in a boat, whenever you need to have some application running on the edge. It's a pay-by-use solution, so it's you pay what you are consuming for, and it will be able to connect with the different equipments that you will have on site, which could be IoT devices, it could be radio access networks, it could be local networks, it could be cameras, sensors, or whatever makes sense. And Angelos will talk about different IoT devices. So this is very secure because we are building VPN connection between the compute devices and the marketplace. The marketplace can even be deployed on-premise if there is a specific need of being local. It can scale to thousands of devices. There is no limitation, and it can work on many different hardwares that have ARM or x86 architectures. Inside this large marketplace, we have many different sectors that we can address regarding artificial intelligence, IoT devices, computer vision for video analysis. This is a video we have seen 2 weeks ago. Monitoring solution for monitoring network and equipments. Network features. It could be as well security, cyber security devices, and as well application around the 5G, like core network, core 5G and 5G monitoring and so. And what we are going to talk about today is about the energy marketplace. And we have the chance to have our partner EPG from Eximprod Group with there today, and Angelos will be able to talk about this application. And it's a partner that we really enjoyed having to be working with, and we already have projects and customers engaged. And it has proved its efficiency, so I'm very delighted to have them today with us. So with that being said, Angelos, I will give you the ball so you can talk about your company and your solutions. And you're on mute, Angelos.
Hi, everybody. My name is Angelos Fountoulakis. I hope you can see my screen and the audio is in good quality. Thank you very much for the invitation. We are very glad to be partnering up with Equinox and Nuvla in order to develop various solutions. Now, I will give you, over the next 10 minutes, an overview of the edge computing solutions that we have been building. But first, I will talk about a little bit of the history and the background of Eximprod. I will show you what we are active in, which is mainly the domain of distribution automation, and go over the specific solutions and their features. There is, at the end of the presentation, a Q&A session. So Eximprod has started for more than 25 years ago to be active in the energy domain. We focus on supporting energy companies to create a sustainable future with our solutions. We are based in Romania. We have a large team of engineers. Our reference customers, we have been working mainly in Europe with various companies like distributors of energy, but also technology vendors. We collaborate with them to integrate their solutions in our projects. 4 activities we perform. As I mentioned, 25 years ago, we began with manufacturing equipment for low voltage, medium voltage, and high voltage networks. So we provide these devices so the distribution companies can build out their networks. Devices like insulators, protection devices, and other hardware. As the technology evolved, automation came into high demand, so we created more than 15 years ago what we call a distribution automation team. This involves software in the central point of the customer, the data center, that is managing and administrating all the assets on the network, controlling energy flow. So this is ADMS system, automatic distribution management systems. And we have developed through our engineering in this domain, custom software solutions. So I belong in the distribution automation team of Eximprod, and I will show you exactly the other activities that we do. Within the group, we also do turnkey projects like EPC contractor for end-to-end rehabilitation of sites. So maybe there is a very old installation that a distributor has. We take care of from civil engineering to mechanical engineering to electrical engineering, end-to-end. And lately, very high in demand, renewables. So from the design phase all the way to the commissioning, photovoltaic and wind parks, delivery to big investors. We are experts in energy, the leading company in Romania and one of the largest in Europe in delivering automation solutions. When it comes to distribution automation, as I mentioned, we have a full range of services from the design to installation, commissioning, acceptance, and maintenance and support, from the smallest microgrid of a renewable station all the way to a national grid operator. Within this team, we have invested in software development skills, and we bring the operational technology expertise from the experience we have collected over the last 15 years into the latest generation of IT technologies, and we use IT technologies like network virtualization, cloud computing, edge computing, to virtualize a lot of the functions that traditionally exist in the operational technology environment. So we created, I'm going a little bit fast directly to the products that we have. We have created 3 groups of software solutions. One is dedicated to distribution automation, and the flagship product there is the ES200, which is the virtual RTU. And I have dedicated slides to show you how this works. This enables remote control, self-healing functions, virtual power quality, and virtual protection functions in the grid. Metering solutions, where we read meters, we collect information from the smart meters, we aggregate all of the information, and we provide artificial intelligence and machine learning algorithms for prediction and analytics. And finally, a dedicated set of solutions around renewables, very high in demand, where we help the customers improve the stability of the grid, integrate easier and better distributed energy resources, and we are using now AI and ML algorithms to do, again, forecasting. When it comes to our solutions and why these are, what are the main characteristics, is mainly scalability, meaning you have the ability to deploy small software packages on the edge of the network and enable various functions that are usually found in hardware appliances. So we take out the physical equipment, which creates an additional burden for the asset director of the operations team, and we virtualize in small software packages exactly the same functions. They are quite powerful because we're using very strong edge computing hardware, and in collaboration with our partner, we use Nuvla IO for centralized management, and very secure, with encryption, with VPNs, with application isolation, and latest technologies on security. The benefits is that you get a system that can connect to existing OT assets, operational technology assets. So we support also legacy technologies. You can easily upgrade the software if there is a new release, either for security patches or new features or new protocols to be supported. You can easily manage the deployment centralized to the edge computing devices. So you have quick upgrade and deployment, and centralized and simplified management. Our flagship product, like I mentioned, is in the distribution automation ES200 virtual RTU, which is a software that simulates the functions that you would find traditionally in a physical appliance. The remote terminal unit is responsible to connect all devices in a node, in a site, and link them to an automation system, a SCADA headend. So that's the job of an RTU. Now, this is also available currently in Nuvla IO Marketplace, and you can deploy it on any edge computing device that is running Nuvla Edge. How does it work? It has 3 main characteristics. One is integrate all signals, data points from the south side, what we call southbound, in a distribution station in a location. It could be a renewable site. It could be a secondary substation of a distribution network. It could be a control node in the field. Those control nodes in the field have multiple protection devices, multiple sensors, multiple equipment that need to be remote controlled or simply read to collect information from it. So our first job is to interconnect all of those devices to the software. The software is running as a containerized application on an edge computing hardware running Nuvla Edge. So as a framework, as an application hosting framework, we use Nuvla Edge. It can be an Equinox router. It could be a Raspberry Pi device. We have tested successfully in the lab with one access, the 2500 series of Equinox and multiple other devices. So we collect all the signals coming from the control devices into the software. And then we map northbound, going upwards, to the SCADA central software that manages and administrates those devices. So job number one is just integrate the signals coming from the devices to a command and control system that can remotely trigger events and read information from it. But additionally, we have the ability to centrally manage with Nuvla IO the applications running on that device. As I mentioned, a new version is published, centrally administrated, pushed through the cloud to the device running on the edge computing node. You can monitor and see the health of both the application and the hardware and obtain alerts. And of course, you have central administration and orchestration of the entire fleet of area network, the entire devices that are deployed on the field. We have additional use cases where we integrate remote sensors. So most of the sensors on the south that I described are local, within a few meters from the gateway. But we have the ability to integrate remote sensors coming from a LoRaWAN network. We have a customer case in Romania that has deployed, for example, in Romania, we have heavy snowfall. In the overhead lines which carry electricity, we have deployed LoRaWAN sensors which detect the amount of weight of snow on the overhead line. So as the sensor moves, raises an alert, and we can dispatch a field engineering crew to clean the overhead lines from excessive snowfall. So this is the core functionality of the virtual RTU. Now, we use the virtual RTU in multiple scenarios. Scenario number one, of course, very high in demand, integrate distributed energy resources. So interconnect with the systems that are located in the renewable site through our combination of hardware, software, and services to the command and control of the investor, because the investor may want to have a mini SCADA system, or the distribution operator responsible for that area, geographical area, because most distribution operators are a natural monopoly in the area where they deliver electricity or they distribute electricity. So very high in demand, renewables. Number two, modernization on an existing grid. So the customer may have a location which is not interconnected to a central control system. We enable the digitization of that platform. Metering is another business use case. So we have smart meters. We need to collect information, other residential or industrial smart meters. And we bring forward the solution where we have advanced cybersecurity, lower operational expenses compared to other solutions, and support legacy systems, because many of these industrial operational technology environments have a lot of legacy devices to be supported. Within the virtual RTU, we have a PLC engine, a programmable logic engine that you can configure with a graphical interface events. So based on the collected data points that we have from the southbound devices, we can create rules with multiple operators that are triggering events based on some thresholds. For example, if the voltage detected exceeds 260 volts, I am experiencing an overvoltage condition, and as a result, execute a certain action to protect the network. Reduce, for example, the power output of a photovoltaic site. I will show you later a specific scenario of how we use this PLC engine. This is very easily configurable by the user. Graphical interface complies with international standard on PLC programming. Again, all of that is running on the edge. Now, the ES200 virtual RTU, when it comes to renewables, we create additional software as satellite pieces of logic that is added on the core ES200 virtual RTU to create a product called Power Plant Controller. Power Plant Controller allows the integration of a renewable site, either photovoltaic or wind, to a central command and control center, like I mentioned. And we focus on residential, industrial, and commercial mainly. Utility-grade systems require different kind of equipment, much more advanced. So our main focus is small to medium deployments when it comes to photovoltaic parks. One example of how we integrate a site, a distributed energy resources site, to a command and control of a distributor is the following. Using a physical router, for example, here I have a Equinox device, running a container with our software, the ES200 virtual RTU, we interconnect with any combination of smart logger or inverter that the customer may have invested in. This is a low voltage site, so it's 10 kilowatt, 100 kilowatt range. There are many players in the market, starting from Fronius all the way to Huawei, producing combinations of equipment. Our job is make sure we interconnect to this equipment. We allow reading of information and allowing control remotely. This allows flexibility for the grid operator. If there is an emergency, connect and disconnect the entire site from the grid. If there is over voltage or there is a problem with the current or the frequency on that area, we can define output thresholds. So you have an installed capacity of 20 kilowatts. Do not export more than 5 kilowatts because I'm experiencing a problem in my network. And of course, collect information from the site. All the power quality information that we can collect. Simple use case, remote control of a remote site. Second case, in the case of a medium voltage installation, where the customer has invested in a SCADA system in itself, we do not want to allow that SCADA system to be able to send any command to our central distribution system or SCADA system. So what we do is we filter and we allow only specific commands on the IEC 104 protocol using our software, again, running on an Equinox device, for example, with Nuvla Edge. And we create an application file to create a security separation between the private investor side and this is critical infrastructure command and control systems. We can also deal with single point information on various protocols in order to treat faults. And of course, we allow the central operator to remote control another site. These are usually larger installations for medium voltage renewables with protection devices, switchgear, and telecontrol. Third use case, and this is basically closing of my presentation, is autonomous control. What means autonomous? Without the need to have a central command and control SCADA system, we can link multiple sites together, which can auto-adjust for both self-healing purposes and lowering the number of faults. You deploy, for example, in a secondary substation, our solution, combining the hardware and software with Nuvla IO marketplace deployment on one-axis routers from Equinox. This ES200 virtual RTU is monitoring the health of the network using a power meter and various sensors. And whenever a condition is detected of a potential fault, we inform the connected sites, there can be multiple distributed energy resource sites, to reduce their output in order to retain the health of the network and the stability of the network. So it's an automated self-healing system. And that, of course, is linked to the first use case of connecting to any smart logger, any inverter, any device the customer may have on his distributed energy resource site. This is the summary of my presentation. It's all about energy control, energy management, optimizing the use of IT technology in operational technology networks, which are sometimes quite critical and legacy. But we have solutions to integrate all of these devices using our ES200 solution, using our partnership with Nubla. This is my presentation. I will stop sharing. I am happy to answer any questions that you may have.
Thanks, Angelos, for the presentation. Yes, there are some questions. One of them is, what are the usual competitor that you can replace with the ES200 solution?
Very good question. Usually you're looking at the standard suppliers of physical appliances of RTUs, ABB, Siemens, and so forth. But these are ranging in the thousands of euros of cost. So we are at least 4 times lower TCO, total cost of ownership, over a 5-year period calculation than the traditional vendors. But you're looking at the traditional equipment providers. They embed that logic in the physical appliance.
And these kind of devices are managed, who are generally the personas that are managing this kind of solution within the customer environment?
They're usually asset directors, the guys who are responsible with all the equipment on the field. So when we talk to a distributor, we talk to the OT division, the operational technology, and there is an asset director. This guy is responsible with the RTU solutions.
Okay.
Or lady, of course. I'm sorry. This person.
No worries. Yeah. And another question, they were wondering if the devices would be monitored, triggered by ES200, would actually have built-in connectivity to the network. So I guess the question is that are these devices, are the IoT devices connected to the network generally?
Generally, no. Many of them, we have the 3 possibilities: GPIO, general purpose input-output, analog or digital inputs or outputs. Second group is serial, and third is Ethernet. The easiest to integrate is Ethernet, and many of those devices are already connected somehow, but we integrate all of the signals. The other types, serial and I/O, are not usually integrated to a central system, and we bring that connectivity. Of course, we need to take over these physical connections into our platform, and we have technical solutions to provide GPIO and serial connectivity. Ethernet, of course, is our bread and butter. Equinox is a great partner. They have a lot of Ethernet options, optical, electrical, so there is no challenge. But to answer the question is, mostly Ethernet is currently connected. The other legacy is standalone on the field, and we bring connectivity to that.
Okay, thanks a lot. Thanks a lot, Angelos. Maybe just a very last interface to show you guys before closing the call. But as you can see in the marketplace, you have the Eximprod ES200 solution that is can easily be deployed. So you can go on it, select the devices that are deployed into the secondary substation on any other environment, energy environment. You have all the information regarding the environment variables and things like that, and you can easily click and deploy the solution. So that being said, thanks everyone for taking the time for the presentation. Thanks a lot, Angelos, for the presentation. It is recorded, so if you guys need to share it with some of your colleagues, don't hesitate. If you can come back to us as well for more discussion. Again, Angelos, thank you so much. I wish you a very good Friday and a good weekend, of course.
Have an excellent weekend, everybody. Thank you very much.
Thank you. Bye-bye.